Grounding bushings are a crucial component in electrical systems, ensuring a safe and reliable path to ground. Their necessity often arises when dealing with concentric knockouts, particularly those exceeding a certain size. Concentric knockouts, also known as reducing knockouts, are a series of stepped pre-cut holes in an enclosure, designed to accommodate different conduit sizes. These knockouts allow electricians to adapt the enclosure opening to the specific conduit size required for a particular installation. However, the presence of concentric knockouts can compromise the electrical continuity of the enclosure, especially where larger knockouts are used. This is where grounding bushings come into play. The primary purpose of a grounding bushing is to provide a low impedance path to ground for metallic conduit and enclosures. This grounding path is essential for several reasons. Firstly, it helps to minimize the risk of electrical shock by providing a safe route for fault currents to flow back to the source. Secondly, it reduces electromagnetic interference, or EMI, which can disrupt the operation of sensitive electronic equipment. Thirdly, it helps to prevent the buildup of static electricity, which can be a fire hazard in certain environments. The National Electrical Code, or NEC, sets the standards for electrical installations in the United States. According to the NEC, grounding bushings are required when the diameter of the concentric knockout is larger than 1 inch. This requirement is based on the fact that larger knockouts tend to create a greater discontinuity in the enclosure's metal structure, increasing the impedance of the grounding path. The increased impedance can impede the flow of fault current, potentially leading to higher touch voltages and increased risk of electrical shock. A grounding bushing is a specialized fitting designed to be installed on the end of a conduit where it enters an enclosure. The bushing provides a secure mechanical connection between the conduit and the enclosure, while also providing a reliable electrical connection to ground. Grounding bushings typically have a smooth, rounded surface to prevent damage to conductors during installation. They also have a lug or screw terminal for connecting a grounding conductor. The grounding conductor is then connected to the grounding electrode system, which provides the ultimate connection to earth. There are several different types of grounding bushings available, each designed for specific applications. Some grounding bushings are made of metal, while others are made of plastic. Metal grounding bushings are typically used for grounding metallic conduit, while plastic grounding bushings are used for grounding non-metallic conduit. There are also grounding bushings that are designed for use with both metallic and non-metallic conduit. When selecting a grounding bushing, it is important to choose one that is compatible with the type of conduit being used and that meets the requirements of the NEC. It is also important to ensure that the grounding bushing is properly installed. The grounding bushing should be securely fastened to the conduit and the enclosure, and the grounding conductor should be properly connected to the grounding electrode system. Proper installation is essential for ensuring that the grounding bushing provides a reliable and effective grounding path. In addition to grounding bushings, there are other methods that can be used to provide a grounding path for metallic conduit and enclosures. One common method is to use grounding lock nuts. Grounding lock nuts are similar to standard lock nuts, but they have a built-in grounding lug. The grounding lug provides a convenient point for connecting a grounding conductor. Another method for grounding metallic conduit and enclosures is to use bonding jumpers. Bonding jumpers are short lengths of wire that are used to connect different sections of metallic conduit or enclosures together. Bonding jumpers help to ensure that all of the metallic components of the electrical system are electrically continuous, providing a low impedance path to ground. When using bonding jumpers, it is important to ensure that the jumpers are properly sized and installed. The size of the bonding jumper should be based on the size of the largest circuit conductor in the raceway. The bonding jumper should also be securely fastened to the conduit or enclosure. The NEC provides specific requirements for the sizing and installation of bonding jumpers. In summary, grounding bushings are required when concentric knockouts are larger than 1 inch to maintain electrical continuity and provide a low impedance path to ground. This is crucial for electrical safety and code compliance. Understanding the NEC requirements for grounding bushings and other grounding methods is essential for ensuring the safety and reliability of electrical systems. Failing to properly ground electrical systems can have serious consequences, including electrical shock, fire, and equipment damage. Therefore, it is important to always follow the NEC and other applicable standards when installing and maintaining electrical systems. When installing grounding bushings, several key considerations should be kept in mind to ensure optimal performance and safety. Firstly, proper selection of the grounding bushing is crucial. Choose a bushing that is specifically designed for the conduit type and size being used. The bushing material should also be compatible with the environment in which it will be installed. For example, in corrosive environments, stainless steel or other corrosion-resistant bushings may be necessary. Secondly, surface preparation is essential for establishing a reliable electrical connection. Before installing the grounding bushing, ensure that the surfaces of the conduit and enclosure are clean and free from paint, rust, or other contaminants. These contaminants can impede the flow of electricity and compromise the grounding path. Wire brushing or other suitable cleaning methods can be used to prepare the surfaces. Thirdly, proper installation techniques are paramount. Tighten the grounding bushing securely to both the conduit and the enclosure. Use the appropriate torque specifications recommended by the manufacturer to ensure a tight and reliable connection. Over-tightening can damage the bushing or the enclosure, while under-tightening can result in a loose connection. Fourthly, the grounding conductor should be properly sized and connected. The size of the grounding conductor should be based on the size of the circuit conductors, as specified in the NEC. Connect the grounding conductor to the grounding bushing using a listed connector. Ensure that the connection is tight and secure. Fifthly, regular inspection and maintenance are necessary to ensure the continued effectiveness of grounding bushings. Periodically inspect the bushings for signs of corrosion, damage, or looseness. Tighten any loose connections and replace any damaged bushings. Keep the bushings clean and free from contaminants. In addition to these practical considerations, it is also important to understand the underlying principles of grounding and bonding. Grounding refers to the connection of electrical equipment and systems to the earth. Bonding refers to the connection of different metallic parts of an electrical system together to create a low impedance path for fault currents. Grounding and bonding work together to protect people and equipment from electrical hazards. The purpose of grounding is to provide a path for fault currents to flow back to the source, tripping a circuit breaker or fuse and energizing the circuit. This helps to prevent electrical shock by limiting the voltage on exposed metal parts. The purpose of bonding is to equalize the voltage potential between different metallic parts of an electrical system. This helps to prevent circulating currents and reduce electromagnetic interference. The NEC provides detailed requirements for grounding and bonding. These requirements are designed to ensure the safety and reliability of electrical systems. It is important to understand these requirements and follow them carefully when installing and maintaining electrical systems. In addition to the NEC, there may be other applicable standards and regulations. For example, the National Fire Protection Association, or NFPA, publishes standards for fire safety. These standards may include requirements for grounding and bonding. It is important to be aware of all applicable standards and regulations and follow them carefully. Grounding bushings are an essential component of electrical systems. They help to ensure electrical safety by providing a low impedance path to ground for metallic conduit and enclosures. Grounding bushings are required when concentric knockouts are larger than 1 inch, according to the NEC. Proper selection, installation, and maintenance of grounding bushings are crucial for ensuring their effectiveness. Understanding the principles of grounding and bonding is also essential for ensuring the safety and reliability of electrical systems. By following the NEC and other applicable standards, electricians can help to protect people and equipment from electrical hazards. Furthermore, let's delve deeper into the technical aspects of grounding bushings and their role in maintaining electrical safety. Firstly, it's crucial to understand the concept of impedance. Impedance is the total opposition to current flow in an alternating current, or AC, circuit. It's similar to resistance in a direct current, or DC, circuit, but it also takes into account the effects of capacitance and inductance. A low impedance grounding path is essential for allowing fault currents to flow quickly and easily back to the source, tripping the overcurrent protection device and energizing the circuit. When concentric knockouts are used, they can create a high impedance path if not properly grounded. The gaps between the different knockout rings can impede the flow of current, especially at higher frequencies. This is why the NEC requires grounding bushings for knockouts larger than 1 inch. Grounding bushings provide a low impedance path around these gaps, ensuring that fault currents can flow freely. Secondly, let's discuss the different types of grounding bushings. There are several types available, each designed for specific applications. Some common types include insulated grounding bushings, metallic grounding bushings, and lay-in grounding bushings. Insulated grounding bushings have an insulating liner that protects conductors from abrasion. They are typically used when pulling conductors through conduit. Metallic grounding bushings are made of metal and provide a direct connection to ground. They are typically used for grounding metallic conduit. Lay-in grounding bushings have a lay-in lug that allows for easy connection of the grounding conductor. They are typically used when space is limited. When selecting a grounding bushing, it's important to consider the specific application and the type of conduit being used. The bushing should be compatible with the conduit material and should provide a secure and reliable connection to ground. Thirdly, let's examine the installation process in more detail. The installation of grounding bushings should be performed by qualified electricians who are familiar with the NEC and other applicable standards. The process typically involves the following steps. Firstly, prepare the conduit and enclosure. Clean the surfaces of the conduit and enclosure to remove any dirt, rust, or other contaminants. Secondly, install the grounding bushing. Insert the grounding bushing into the knockout opening and tighten it securely. Use the appropriate torque specifications recommended by the manufacturer. Thirdly, connect the grounding conductor. Connect the grounding conductor to the grounding bushing using a listed connector. Ensure that the connection is tight and secure. Fourthly, inspect the installation. Verify that the grounding bushing is properly installed and that the grounding conductor is securely connected. It's important to follow these steps carefully to ensure that the grounding bushing provides a reliable and effective grounding path. Furthermore, ongoing maintenance is essential for ensuring the long-term effectiveness of grounding bushings. Regular inspections should be conducted to check for signs of corrosion, damage, or looseness. Any loose connections should be tightened and any damaged bushings should be replaced. The frequency of inspections will depend on the environment in which the grounding bushings are installed. In harsh environments, more frequent inspections may be necessary. In addition to visual inspections, electrical testing can also be performed to verify the integrity of the grounding path. Ground impedance testing can be used to measure the impedance of the grounding path. A low impedance value indicates that the grounding path is in good condition. A high impedance value indicates that there may be a problem with the grounding path. If a problem is detected, it should be investigated and corrected immediately. Finally, it's important to remember that grounding bushings are just one component of a comprehensive grounding system. A complete grounding system includes the grounding electrode system, the grounding conductor, and all of the bonding connections. All of these components must be properly installed and maintained to ensure the safety and reliability of the electrical system. In conclusion, grounding bushings play a critical role in electrical safety by providing a low impedance path to ground for metallic conduit and enclosures. They are required when concentric knockouts are larger than 1 inch according to the NEC. Proper selection, installation, and maintenance of grounding bushings are essential for ensuring their effectiveness. By understanding the principles of grounding and bonding and by following the NEC and other applicable standards, electricians can help to protect people and equipment from electrical hazards. Let's further explore the nuances of grounding bushings, particularly focusing on specific scenarios and advanced techniques for ensuring optimal grounding performance. Consider a situation where multiple conduits enter an enclosure through concentric knockouts. In this case, it's essential to ensure that each conduit is properly grounded. This can be achieved by using a grounding bushing for each conduit, or by using a bonding jumper to connect all of the conduits together. The bonding jumper should be sized according to the NEC requirements and should be securely connected to each conduit. Another important consideration is the type of enclosure being used. Enclosures can be made of metal or non-metal. When using metallic enclosures, it's important to ensure that the enclosure is properly grounded. This can be achieved by connecting the enclosure to the grounding electrode system using a grounding conductor. When using non-metallic enclosures, it's important to ensure that the equipment inside the enclosure is properly grounded. This can be achieved by using a grounding conductor to connect the equipment to the grounding electrode system. In some cases, it may be necessary to use supplementary grounding electrodes. Supplementary grounding electrodes are additional grounding electrodes that are installed to improve the grounding performance of the system. They are typically used in areas with poor soil conductivity or in areas where there are high levels of electrical noise. When installing supplementary grounding electrodes, it's important to follow the NEC requirements for spacing and depth. Advanced techniques for ensuring optimal grounding performance include the use of surge protective devices, or SPDs. SPD are devices that are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, switching operations, or other disturbances on the power system. SPD work by diverting the surge current to ground, protecting the equipment from damage. When using SPD, it's important to ensure that they are properly grounded. This can be achieved by connecting the SPD to the grounding electrode system using a grounding conductor. Another advanced technique is the use of harmonic filters. Harmonic filters are devices that are designed to reduce harmonic distortion in the electrical system. Harmonic distortion can be caused by nonlinear loads, such as electronic equipment. Harmonic distortion can cause overheating of equipment, increased energy consumption, and other problems. When using harmonic filters, it's important to ensure that they are properly grounded. This can be achieved by connecting the harmonic filter to the grounding electrode system using a grounding conductor. Furthermore, it's crucial to stay updated with the latest revisions of the NEC and other applicable standards. The electrical codes are constantly evolving to reflect new technologies and best practices. By staying informed, electricians can ensure that they are using the most up-to-date methods for grounding and bonding. In addition to technical knowledge, it's also important to have good communication skills. Electricians often work as part of a team, and it's essential to be able to communicate effectively with other members of the team. This includes being able to explain technical concepts clearly and concisely, as well as being able to listen to and understand the concerns of others. Finally, it's important to have a strong commitment to safety. Electrical work can be dangerous, and it's essential to always follow safety procedures. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and following lockout-tagout procedures when working on de-energized equipment. By following these guidelines, electricians can help to ensure the safety and reliability of electrical systems. Grounding bushings, while seemingly simple devices, play a critical role in this effort. Their proper application and maintenance are essential for protecting people and equipment from electrical hazards.